Hello, everyone. Welcome to the AAAI podcast series. My name is Ella, and the name of the series is going to be called Generations in Dialogue. Through this series, we're aiming to represent diverse perspectives across generations so as to foster rich conversations about the ever-changing landscape of AI. Generations in Dialogue really aims to feature unique outlooks from AI experts to practitioners to enthusiasts of all backgrounds, and each episode will cover important topics ranging from delving deeper into the history of AI to exploring future ethical implications of its newest technologies. So, our first guest is actually going to be Professor Veloso. We are so excited to have her. Professor Veloso is a distinguished computer scientist known for her pioneering work in artificial intelligence, particularly in multi-agent systems, robot and human AI collaboration. She's currently the head of AI research at JPMorgan Chase and previously served as the Herbert A. Simon University Professor at Carnegie Mellon University, where she was also the head of Machine Learning Department. Professor Veloso, we are so excited to have you today.
Thank you for having me.
All right, I guess we'll dive really quickly into a few questions now. So, what exactly inspired you to explore your research direction of exploring AI systems?
Very good question. I actually studied electrical engineering as an undergrad degree,
Okay.
and I developed an understanding that computers, one way or another, could help humans in their tasks. I did a master thesis on trying to automate some kind of processing of an industry, a manufacturing industry, and I was very impressed by, in those days, to understand that humans were doing many tedious tasks and computers could do it instead. So my love for AI does not come from reading some kind of science fiction books or from thinking about understanding the nature of intelligence. It was very pragmatic on trying to bring computing to tasks that representing knowledge well, representing process well, that to alleviate the effort of humans doing many things by hand.
Very interesting. Was there like maybe a specific task that you thought definitely like machines are able to accomplish this? Like,
Yeah, very nice. So the tasks that there are many tasks even now where I am that basically involve how do you say, gathering a lot of information, for example, all the parts of a particular product that you need to put together, and then literally setting orders of all the parts, connecting like orders with the actual manufacturing of the parts. We call these list of parts. And all those were very extensive, and then you had to know and keep inventory and knowing all sorts of like managing this type of information in and out, how much needed, the timing, all the scheduling and management of such products. And so that's basically the first understanding I had of computers being able, AI being able to handle the scale and the optimization and the management of all this information in a very accurate, way.
that's actually super interesting. I did not know that. I feel like a lot of the time, maybe when people like read your research, they are a lot of the time, people have like different ways of being able to get into AI research. So it's so fascinating to hear about exactly what led you to begin your journey. Amazing.
And just one final thing, Elle, I'll tell you. So when I did this, so I noticed that many things were similar to other things that people had done in the past. So this product was basically that one, except for a few things. So I developed an interest on actually having AI learn by analogy. So my PhD thesis later on at Carnegie Mellon University was in fact on planning by analogy, which was about using past plans and literally adapting and changing them so that they would apply to a new situation, but you would not solve the new situation from scratch. You would always like think first, oh, did I ever do something similar in the past? Oh, how many similar things did I have done? And then the AI system, this AI algorithm that I developed, would grab these similar pieces and plug them back together to address a new situation. So it was all this planning by analogy that came from my experience one way or another of working in that factory in which things were very similar except for minor details.
That's super fascinating. And I feel like that's also like one of the mentalities right now that a lot of AI researchers are kind of being able to adapt, right? Whether it be in terms of optimizing efficiency or being able to generalize a specific model to do many things, right? We have like NLP right now. So yes, that's super, that's so interesting. I'm just wondering, how has your perspective maybe evolved over time through the different
Very,
experiences you've undertaken?
very good question. So
Mhm.
let me explain to you. So I had done a lot of little algorithms to represent, to optimize this type of like management of information process. And then I came to Carnegie Mellon. At Carnegie Mellon, like I told you, I did this thesis on planning, which means like generation of steps by analogy. But then when I was in finishing my thesis, 1991 or something, this is a generational kind of like moment. I was in a talk with Alan Newell, who was at Carnegie Mellon. Herb Simon was in my PhD thesis committee, but Alan Newell, I was basically taking classes with him. He did something remarkable. So he entered this room, and on the blackboard, he picked up this big chalk, and he wrote on the board perception, cognition, and action. And then he wrote underneath agents. So he kind of like made us understand that the goal of AI was not the individual components of like natural language, machine vision, planning, optimization, but it was about putting it all together. And so I was sitting there finishing my thesis on planning by analogy, and literally I wondered, oh my gosh, these agents are amazing. They are going to be able to process data, they're able to make decisions and actually execute them. And that's when I switched, or would not switch, but I evolved to understand the concept of execution also. Having AI not just providing the information, but AI also actually executing, deciding and executing. And that's what led my career after I finished my PhD all into AI in robotics, because robots ended up being this framework in which the perception, cognition, and action could be all beautifully integrated to achieve tasks. And then the part that makes me that makes me not exactly just a plain robotics person, but I'm AI in robotics, is because I was obsessed by have them execute tasks, work on problems. And robot soccer was an example, then service robots was another example. So I was always worried about the actual having them do things, not having the best motors or just the best vision system or just the actual great planner or motion planner or localization. So always those were pieces towards solving the complete task. And so I always cared about the complete task. And that's how I evolved from, managing information to a thesis on planning by analogy to eventually work on robotic agents, on robot
That's
agents.
incredibly interesting. Yeah, I feel like you're focused on the actual application of technology or like the impact to make sure it's almost like the innovation or like the new technologies that you're using actually get put into like a beneficial user case. That's super inspiring, actually. Do you think there were any challenges maybe that you faced while you were trying to make this transition?
Very much so. I mean, I had never worked with actual hardware,
Mm.
and even like cameras. I was very fortunate that professors at Carnegie Mellon and other groups, supported these research and provided help with the cameras in those days were not as easy to access, and we didn't have many algorithms for actual vision. So this was all the beginnings. And I was very fortunate also to have PhD students who in those days were not only interested on the internet, which was what was starting in those days, but they were very interested on actual the robots, the actual physical space. So because of that, we went and moved on into this task of robot soccer. So I had students very interested, in particular, Peter Stone was my student, Astro Teller was my student, and other like Jim Bruce, Sonia Chernova. I mean, all my students are available off my webpage, but it was like more this kind of like understanding that we could build robots that executed tasks. Karen Haig was my first student on really this kind of like having a robot that learns from execution, a tremendously impactful thesis in terms of algorithms. So, I mean, in this conversation, I apologize to my students up front if I don't mention them all, but it's definitely it's again an intergenerational kind of contribution. It was definitely all the work I've done with my PhD students that shaped my thinking, that drove the research. So it was always this collaboration with the PhD students, amazing PhD students that I had at Carnegie Mellon.
Amazing. And it's so inspiring to hear you talk so highly of your students, right? Like they're representative of our next generation. So I guess on that note, I also think it's fascinating that you were mentioning how cameras back then maybe weren't that accessible. I feel like it's crazy to think about how like from just a few years ago to now, we have so much more accessibility to these kinds of technologies. So we're incredibly grateful for that. How do you think in general that there's a generational shift in AI researchers' priorities and being able to influence the trajectory of AI applications?
So, this is definitely the case that things are changing, let alone basically influencing the research directions, even mine. So what happens is the following, and I want to use this opportunity to clarify this winter of AI. So what happens is that somehow, think about the mid-50s, not even to think about Alan Turing, but think about the mid-50s with the Dartmouth conference. And literally people wanted to have machines that executed, that captured all the aspects of learning, all the features of intelligence, and they could execute tasks that humans did. So AI started with a very ambitious goal, extremely ambitious, when barely there weren't any computers. I mean, think about that. There were what, like the big ENIAC that would take the whole basement? Who knows? So think about having that goal, and the substrate for the goal was not that common. I mean, and so these researchers are actually remarkable. The beginning of AI is remarkable in the sense that they didn't give up. They could have said, we don't even have computers. So we don't have internet, we don't have anything. Why are we going to engage our minds and our efforts, research efforts towards this goal? It's remarkable. So one of the approaches that they had was this knowledge, to acquire knowledge from humans. So they didn't have internet, they didn't have anything. So literally these expert systems kind of like approach would involve these humans, these researchers, ask these other experts on doctors, on construction, I don't know, how do they make decisions? And literally they were, how do you say, acquiring the data that would eventually feed into their algorithms to try to replicate the same tasks. So I have a tremendous admiration for the fact they didn't give up, that they persisted on trying to pursue this goal. And then it's true that eventually this asking the humans did not prove, scalable. It didn't. You can still, you could not like kind of ask, how do you prove a theorem in geometry? How do you do this? Imagine every single thing. How do you play chess? Tell me everything you look at. Every single thing asking humans. So in parallel with this kind of approach that turned out to be not scalable, the internet came up. And the internet is now bringing you all this information, books that are scanned, everything, data, cameras that, the iPhone came up. Now you have pictures online, thousands. So think about the change. And somehow this substrate enabled different approach to AI now. Because of the iPhone, because of all the sensors, because of everything, of all the books being scanned, the language was available, images were available, AI transitioned to being a science of trying to use all that data. I mean, instead of being a science of extracting from humans, how do they make decisions? Now, you have a wonderful approach now of taking advantage of such enormous amounts of digital information available. So now, of course, the approach changed because now we became, how does machine learning works on all these data? Now, Gen AI, how do we actually build upon all these language models that are coming up? But look, there's nothing wrong with how it was before, how it is now. There is nothing. It's just that technology evolved. It's like the Gutenberg days of having now a printing press. I mean, now books are available for everybody. I mean, okay, the people before Gutenberg were not reading. Oh, yeah, but they didn't have books. So you have to understand that the advances of technology, and who knows where we'll go, maybe like even faster machines, sensors everywhere, who knows, open changes in some sense the approach that AI has been following. And that's really something that I hope that generations to come open their hearts to this tremendous beginning, be it Turing, be it Ada, Babbage, Lovelace, all the way, these beliefs that machines could be intelligent using what was available. So it's not really the case that people have an intention when they were doing expert systems not to use data available. No, it's just that there wasn't any data available.
Exactly. And I feel like, again, it's absolutely insane to think of how much progress that we've been able to make from then on to now, and how we've been able to really, because of how much data is available, AI has become a lot more accessible. Right now, it's like not just making sure we have enough data, but making sure that it's inclusive, representative. So yeah, that's incredibly fascinating. I do remember you talking about how you have incredible respect for the researchers who did like research before you, even in times like where there was even less resources available. So I guess you talked a little bit about how you worked with your PhD students. Could you share maybe another moment where intergenerational collaboration with maybe the older generation really significantly influeed your overall research direction?
Very nice question. So I did mention that agents on the board, which was a very important. And together with that experience at Carnegie Mellon, interacting with these, Herb Simon, Alan Newell, Raj Reddy, all these big names of AI, I learned that it was, and Alan Newell said that I was supposed to work on what I love, do what I love, and love what I do. That always made me not be driven by what people want to know or what people eventually love to hear, but what I love to do, and then do what I love. And I also learned from Alan Newell that in some sense, my life would not be a random walk through publishable material. I mean, in the sense that you want to have, so I learned these, that you want to have your own love for AI, your own love, and then contribute to the world whatever you love. But there is one thing that I want to say about the other way. So I had a postdoc at CMU coming from MIT in those days, Tom Collar. And he was a big influence in my research, even as of today, together with Vittorio Pereira and other of my PhD students, in the following way. So we had this cobot robot, which was a service robot, move around the corridors at Carnegie Mellon. And literally, this robot had limitations. So it was on wheels and didn't have any arms, and literally could not open doors, could not do many things. And I had, with my students, Stephanie Rosenthal, Joy Bisbas, and Brian Colton, we had introduced this concept of the robots asking for help. So they would ask the humans to press the elevator button, and they would ask the humans to hold the door. They would go in. They would ask the humans to put things in their basket, everything that was manipulation, and they didn't have arms, to actually ask the humans around to help. So this was a very beautiful kind of way of thinking about symbiotic autonomy, in which humans and these robots would be filling up for each other limitations and capabilities. Really beautiful. But then going back to Tom Collar, in these ask for help, basically we wanted it also to interact through language with people, the robot. And we wanted the people to be able to tell, hey, cobot, take me to Manuela's office. Hey, cobot, where is coffee in the building? Hey, cobot, where's the conference room? We wanted this interaction. And so I had an approach in which I told my students, and Tom in particular, let's put all the database of locations, so all that knowledge into the robot. And then Tom said, no, we're going to have an approach in which it learns over time. So, which was like this. It was unbelievable. And I want to raise these because now with Gen AI, we don't have it yet, which is like this. This robot would ask when it did not know. So, and these robots, so if I started the first time saying, okay, go to Manuela's office, he would go to a kind of like database or some kind of like file with everything it knows already, and it would see that Manuela's office was not associated with any location in the building, which was the things that Cobot knew about. So it would literally say, well, where is Manuela's office? Can you please tell me a room number? And then as soon as this human would say, yeah, it's 7209 or it's 7002 or something, it would save Manuela's office, as I had spoken, I mean, the speech itself, Manuela's office, plus all the interpretations that the speech recognizer might have given Manuela's whatever or something, lunch, bunch, whatever. So all these with 7002. And so it acquired that. It was not learning from a tremendous amount of data, but it was learning from this interaction. And then next time, if you would say, oh, I would love to go to Manuela Veloso's office, which was not exactly there, but the machine, this cobot algorithm would like propose, do you mean 7002? And then the human would say yes, and it would reinforce. It would reinforce this. So it acquired and learn the whole map of the building, what things were where, coffee and this and that, by literally acquiring them from what humans said. So humans were helping, but as opposed to pressing elevator buttons that you cannot do because you don't have arms, this was cognitive limitations. It did not know where Manuel's office is, where is coffee, and it asked. I think it's remarkable, this concept of asking and then learning from the asking. So that was something that very much changed the way that I looked at problems, because instead of just thinking about all this data, feed it to some neural net that it learns, you are now like learning incrementally by the interaction with humans. And eventually you converge to all the things that people say about the building, and you are done. See, so that's something that really transformed the way I'm thinking. And the reason why I'm saying it's very relevant now is because this Gen AI might have hallucinations and these, but it never tells you like this, I don't know. Please tell me, so I'll remember for next time. Okay, it might remember things from dialoguing, but when do you see these things saying, I don't know, tell me so I can learn?
Yeah, I feel like they'd rather share maybe like false information than accidentally be like, I actually don't know. Yeah.
I know. Crazy. Anyway, so that's one example. But I do want to just give very briefly another example of something that very, very important. All the people that were working with me, Jim Bruce, Brett Browning, Michael Bowling on robot soccer, you know, our code at some point became spaghetti, a mess. You know, after 2 years, you add here, you put there, the motors change, the planning change. I mean, it's just a mess. And at some point, my students, Jim Bruce in particular, and Michael Bowling and Brett, stepped back and said, we have to think about these agents, these multi-agent systems in a different way. And they introduced an architecture for AI called STP, Skills, Tactics, and Plays. So they broke the whole task into little pieces. And they said, okay, let's not worry about how we play against this team and against the other team and what plays we are supposed to do as a multi-agent system. Let's first define all the capabilities of a single agent. So they introduced these skills. Skills were basically little actions like in planning go to point, face direction, find a pass ball. They were like all little skills, and we enumerated them all. We wrote optimized code to go to point, avoid obstacle, face the ball, find the ball, whatever. And then tactics were methods to achieve goals in which you would put these skills together. So very beautiful concept of like, okay, if you do pass to someone, okay, first, so the other one had to go to the position, this one had to go to this position, and then the pass would take place. So it was a sequence of skills well worked together. And then plays were how the multiple robots would interact. Would we play 3 attacks for defense? How do we divide the task between all the agents? And so these skills, tactics, and plays, and I want to give all the credit to the discipline of having reduced the code or rewrite the whole code along this, enabled us to run these robot soccer teams in my lab for almost 20 years, with students leaving, PhD students leaving after 2, 3, 5 years, new coming in, and everybody could use that code, that AI system that was so beautifully kind of like structured with this STP architecture that you could put more plays, you could change the algorithm that would do localization, you could change this, you could change that, and everything still worked together. So that's a very beautiful thing, because just to finish this thought is like this. For me, AI is not a one-shot thing. For me, AI, when you developed AI in your work, it's not classifying cats and dogs, or, it's not really a one-shot. It's about building something that is a journey, improves over time. So in order to have that discipline of thinking of AI as not just this particular problem, but how does it go over time with you, you need to structure the code or you need to structure the thinking, not for this particular task, but how does it get better over time? Does it have weights that we can adjust? Does it have more skills that we can learn? Does it have more plays that we can actually add? So the whole paradigm of making an AI system, robust over time, I adjusted to think this way through also the interaction with my students. I mean, they were the ones that understood that they had to leave, and how could others follow up?
Yeah, it's so
Very beautiful.
Yeah, it's so fascinating how I feel like almost like the two examples you were talking about. It's like kind of how AI was able to work with humans as a team, and then also how your team, when developing AI, was able to work as a team, like really be able to like collaborate and ensure everyone was kind of on the same page and asking questions and improving clarification. I feel like that's such an interesting concept that yeah, has really allowed for us to progress to where we are across generations, across species even. So that's super interesting. I guess on the same note, is there maybe another critical lesson that you say you've learned from an earlier AI pioneer that's still relevant today?
Very good question. So let me just tell you that in some sense, how can I say? There is something else that we need to understand. That AI is not done. I mean, it's not done. No matter how much Gen AI we have, we don't use Gen AI to play chess, or we don't use Gen AI to generate routes in Waze, or so. And what I think is that I hope that because of the power of Gen AI now, or because of the power of particular kind of developments in AI at any moment, that we don't lose a big heart for AI. So we cannot become just this particular technology, be it reinforcement learning, be it deep learning, be it like expert systems, whatever was the steps throughout this journey, we still need to understand that our ultimate goal is to have around us humans, cats, dogs, and robots, and AI as part of your assistance. So how do we get this assistant level? We go to sleep, and AI doesn't need to go to sleep. So how do we task this thing? Oh, I have this very difficult case here. I'm a doctor. Can you please help me figure out the diagnosis for this? And you just go to sleep, and AI in your background does this. So, I have a human assistant, a phenomenal human assistant. But I think that one day we might have assistants, AI assistants, much more. Who knows if they use Gen AI or if they use planning or if they use thing, is more like growing our heart for this ability for computers to help us in our daily lives.
I think that's super
Oh,
interesting.
anyway, so that's how I feel about, in some sense, what we should have people understand is this bigger picture about AI.
Yeah, it's kind of almost like an ecosystem between how are we able to best optimize the relationships between AI and humans to ensure AIs are actually like benefiting humans rather than like trying to replace it, which I feel like is currently like a negative mentality that some people might have towards it. So I think that's definitely very reassuring to hear from somebody like yourself. Then yeah, I guess diverging a little bit. So you're obviously at JP Morgan right now. How do you view the evolving role of AI in fields such as finance and other like traditionally like human-centric industries?
A very good question. And indeed, the reason why, in some sense, I joined after 30 years at Carnegie Mellon doing machine learning and robotics and AI and teaching and advising students and came to JP Morgan heading this AI research group was because, in fact, someone here mentioned, do you want to join a place where that was not born digital? So, as opposed to Amazon or Microsoft or Facebook or Meta or Google, they were all born digital. And they were all born already thinking about computers. Now, this industry was not born digital. And that for me was a big, how do you say, a big challenge. I'm like saying, oh, really? So, how do people do this? So, here in these industries that were not born digital, one way or another, they function really well because they rely a lot on humans. Of course, they rely a lot on digitalized information. You don't see almost anywhere any papers. People have Excel files, they have Outlook, they have Word documents, they have PDFs. They have websites. They don't have necessarily everything done by hand, human way. But the reasoning part and eventually the processing of these very large amounts of information, AI can help a lot. So it has been an eye-opening for me being here and trying to understand how can AI contribute to actually, or how is AI contributing? Not it can, it is contributing for making all these industry much more effective with respect to its customers, with respect to its values, with respect to actually the processing of the data. So everything is very, very large. And the domain of finance in particular is very appropriate for AI to help along not only the document level, but also the number level, and actually also the optimization level and the learning from data. I mean, which captures so many patterns that can be of benefit to understanding them. So, if you ask me like this, what about if you had gone to agriculture? Agriculture would have enabled me. I would have gone too. I mean, or kind of like health, because the reason why I'm saying I would have gone too is because I think that I was curious to do something else, and to try to explore another domain, another problem from the inside. But agriculture would have made me like probably delve more into climate, or health would have made me delve much more into images and treatments and people. So here I'm more focused on people, numbers, and literally, so these documents, all sort of text. So you have documents, you have humans that you have to work with, and then you have all these numbers that have to be all right. So finance seems to be these three pillars, and we are developing solutions of AI for all these different challenges.
Yeah, that's super interesting. And I love that you're like focusing a lot on like not just the impacts of AI, but also like its interdisciplinary connections with different fields. Because as you were saying, right, AI is just reliant on data. So it's like if we have AI, we have humans, we have data, then like AI is able to increase our ability to be able to identify these kinds of patterns, even if it's incredibly complex and non-linear. So that's super interesting. I guess in that similar sense, it's like now everyone probably, even if they don't necessarily consider themselves to be technical, it's AI is somehow relevant in their field as well. So do you have any advice for younger researchers on maybe how to be able to navigate this new AI landscape when it comes to like deploying AI at scale, for example?
A very good question. So, Ella, they're very nice. So, my final comment and advice for other people, or at least based on my humble advice, I don't know, is the following. So, data captures a lot of like the, how do you say, the raw information that's available by us functioning in the world. But there is something that that I'm working on now, and I question, which is the knowledge that humans have. So the knowledge that humans have. So I think the challenge is to capture also that knowledge. I give you an example that's actually very interesting. I mean, I think so. If you actually show tons of examples of games of tic-tac-toe, suppose that you find the representation and literally you tic-tac-toe is on the web, so if you ask ChatGPT, it will tell you what it is. But imagine a game that you only give examples, you only give all sorts of like runs of the game. And then you ask ChatGPT, or no, I'm sorry, you ask Gen AI or AI for what are the rules of the game. The ability to generalize, let's think about tic-tac-toe. The ability to generalize to say, oh, your 3 marks need to be aligned in a row, in a column, in a diagonal. You win the game if you are able to put your 3 things in these column, row, or diagonal. You take turns. You have 1 mark cross and the other person has circle. Look at that. From examples to extract these abstractions. Complicated. Now, the AI will learn to play tic-tac-toe and beat you all the time. But the AI is not able to tell you what are the rules of the game. The AI does not know how to teach you to play. So now, one day, and I tell you for this younger generation, that it's not as much about machine learning because we have all the data. What about machine teaching? How do we get to the point that this machine can teach you E equals MC squared, the Pythagorean theorem, not give you examples 3, 4, and 5, but tell you that A squared equals B squared plus C squared? How do we go there? Humans are experts at generalizing, at abstracting, at coming up with like principles, with rules all the time. All the time. It's actually something that we have to embrace to try to include in these AI systems also this type of knowledge. So I have a long experience. I'm not dropping the knowledge that people have and try to combine it with data. So the data are facts, I mean, are examples, but then how do I teach tic-tac-toe to someone? I could always win, but can I teach? Probably not. So this is what you have to understand. And you just said also just Ella before, so AI does depend on data for many things. And it's the strength of AI is the ability to actually use all these data. But there
Exactly.
is more to intelligence than data. There's
Mhm.
more to intelligence than data. And I really think that sooner or later, we have to think about capturing that knowledge, generating that knowledge, and being able to function with humans. I don't want examples of tic-tac-toe. I want the rules of tic-tac-toe.
Mm. Yeah, I feel like that also just reminds me like there's now like a focus on not just like AI being able to like solve for a specific problem, but also being able to explain their thought process,
Exactly.
right?
Exactly.
Yeah.
The explanation The explanation in terms of actually inventing a new term, diagonal, row,
Yeah.
column. It's not there visible in anything. But with Gen AI, one way or another, I do believe that these abstractions are, for concepts, are all available. If you talk about cats, dogs, and cows, the Gen AI tells you these are animals. So that's remarkable. So these abstractions exist. Is more in procedures, like the rules of the game. You do this first, you do that first. That reasoning part and coming up with those type of generalized procedures from examples, we are working on that, and that's like something that I think is a very important connection with humans, who, exactly like you said, they need an explanation of a nature that includes an abstraction one way or another.
That makes a lot of sense. Thank you so much for answering. And I guess the very last question that I'll ask today, because we're almost at our time limit, is what exactly excites you the most about the intersection of interdisciplinary collaboration or generational perspective shaping AI's future?
Very good. Again, what excites me most is to try to reach the ultimate goal of AI, which is to have these creatures, these non-human creatures, be of value to humanity. And so what excites me most is the things I was telling you about, trying to connect human knowledge with computers, algorithms, try to make these computer algorithms evolve over time. And I want to explain also just one thing that you just said, the biases, all these dangers of AI. So there are many dangers of AI. AI can be misused like any other technology, and we just have to educate our world in a way that the good users are more than the bad users. But what matters is that if we look at AI as having biases, or what I hope people understand is, what we don't want is for AI to remain biased. There has to be a way to be able to say, no, you should have done this instead of that. No, you have done this. So how do we make these AI, what excites me more is about developing these AI systems that become better over time, in which AI is this journey between computers and humans in a way that they optimize how the two together better solve the problems of humanity.
Exactly. It's like rather than amplifying the biases, we're able to provide feedback to ensure that the AI
Exactly.
knows when it does something wrong or when it doesn't know something. Amazing. We're kind of at a full circle now. Thank you so much for coming on here and for
Yeah.
answering all of these questions. Yeah, we're really excited. We really are grateful to have you on this exciting journey. And to anyone who is listening, again, whether you are an AI professional, researcher, or student, we really encourage you to utilize this platform to be able to share your unique perspectives of AI with a global audience. Yeah, so thank you so much, Professor Veloso, for having us, and we're so grateful to have you here. Thank you so much for your time. And all right, that concludes the end of the first episode. We'll see you in the next one.
Thank
Bye-bye.
you for having me. You were excellent, Ella. Thank
Thank
you.
you. Bye-bye.